Okay, welcome back. I do remind everyone that participated in the Flash Talks to vote. Now the Google Docs should be shareable that you can edit and vote. What we're trying to do again in the morning is to go over more of the theory, and in the afternoon go into hands-on and practice. So something that is uniquely happening nowadays days is that the idea of practice, what does that entail? Do you actually need to be in front of an instrument? How much can you do remotely versus on site? And cryoVR, which you'll hear shortly, is really making a lot of headway into trying to allow people to safely practice and learn best practices before they get to instrumentation. Because as we're moving forward to a more centralized model, how do you better equip yourself to be as efficient as possible? So Wen Jian and Victor Chen here have been working on augmented reality and cryoVR at Purdue to try to assist users in learning how to make use of not just sample prep equipment, but trying to extend that to other parts of their workflow. And I'll give the floor to Wen.
Okay, thank you, Ed, for inviting Victor and myself and our team to give this presentation here. So, okay, so just a very brief introduction to our project, our team. So we were funded by the NIH Transformative High Resolution Cryo-EM initiative. This is the same initiative that funded the 3 national centers and then ET centers. As part of it, we also among a few this curriculum development tips. So as Ed just pointed out, our angle is from the virtual reality angle. So our the actual motivation, inspiration was mostly from our own learning and also the training needed in our own facility, where we realized that we have this very expensive equipment and very often only one copy of the equipment. We want to reserve those equipment, right, for the most productive use. But at the same time, for training, we also need access to those equipment. We saw that maybe virtual reality can save us a little bit time using the VR as a pre-training, so that the new users can get at least become familiar with the interfaces, the instruments, and the basic operation procedures. So to get a majority of the orientation part done, then once the trainees get on the physical machines, so probably we'll save, maybe half some time on the physical machines. So at the same time, I also want to avoid some called rookie errors. Hopefully, the entire experience through the VR pre-training can increase the training efficiency, learning efficiency, at the same time also training capacity of the facility. So Victor is the expert in learning. One of the benefits, hopefully we can fulfill the benefits, is how we learn by doing, right? I think according to Victor, the learning series, learning by doing is probably very efficient, especially for the operation, hands-on operation based tasks. So hopefully cryoVR can help us deliver that. So before I go to the actual details, I will just show you a very brief overview of our cryoVR projects. So give you a big picture of what we do. So I will start playing this.
cryoVR is a virtual reality training application designed to help users improve their skills and experience on cryo-EM procedures and instruments. Currently, there are 5 cryo-EM procedures simulated in cryoVR. These modules include glow discharge, VitraBot, CP3, autogrid clipping, and autogrid loading. A mouse-controlled PC version of the VitraBot module has been developed to help users without virtual reality equipment gain an understanding of cryo-EM procedures. cryoVR has 3 different modes implemented to meet the various needs of users during training. In tutorial mode, detailed text, voice, and user interface guidance ensure that users are assisted whenever they encounter any difficulties.
It's time to add FA to the workstation.
Exam mode is designed to test users' knowledge and skills. Users can log in with their ORC ID to record their performance during training. If the user passed their exam, a cryoVR certificate will be sent to the user's account. cryoVR can be downloaded from our website to enjoy features such as the replay system and safety and hazard simulations, and explore many more possibilities through virtual reality training.
Okay. Yeah, so now you get a brief overview of the cryoVR. So I'll go into some details. So since we have just a small audience, right? So you're welcome to interrupt me and ask questions if you would like. Or we'll also have time for more question and answer at the end. Yeah. So currently, cryoVR in our first the development phase, we will aim at the single particle cryo-EM workflow. So we started with the glow discharge to prepare the grease, right? So then simulate the plunge freezers, get a good grease. Then load the grease to the autogrease. We clip the autogrease and then load the autogrease into the Titan cryos. So so far we have implemented the cryoVR modules for all these steps. So in the very first step, glow discharge, we simulated the easy glow machines. And for the plunge freezing, actually, we spent more time, and we have completed 2 devices, the VitraBot Mocha 4 and the Gatan CP3. Actually, later I will tell you, so we're also making model for the Leica GP2 as well. So we completed the autogrid clipping and the autogrid loading modules. So all those are available on Windows. That's the primary platforms. And the facilities might only have access to Linux machines for this. We'll also try to make that cryoVR models on the Linux as well. And so for the learning, especially the early stage learning, right? So before the user get familiar with particular instrument, so we really need this guided tour, right? So we implement multiple modes. Started with the tutorial mode. We will show you what we have in the tutorial mode. Then once the user getting enough this guided tours, then we'll implement the called practice mode, where we will remove all this guides and then let the user play. So make sure that you can play without a guidance to completion. And then we have the final mode, exam mode, so that you are sure that you truly master that. We'll get more details in a few minutes. So first, the tutorial mode, we try in the cryoVR, we try to integrate all this nice teaching learning approaches we had in the past, right? So in addition to the virtual instruments, we also integrate the text and the audio instructions. For example, in the virtual scene, you look up a little bit, then you will see the text instruction on the wall and concisely stating what this step is and then what do you do. And also same time, the audio also read out this instruction to you. So we also try to embed the relevant shorter video clips at each of the steps of the operations. For example, this just shows one of the clip of Grant explaining sample preparations. So, so some depend on what task you are working on right now. So, right, the kind of operation might be different. For example, this particular short clip shows, right, for opening the valve, the Eastern tank, right, so need twisting actions. So we have this, this circular arrows, right, to show you this is the proper actions. So we have this video queues adapted to each of the operations. And so some of the tasks, right, require a certain time amount of time to wait, a few minutes, for example. So in the VR, we try to implement the understanding that you do need to wait, but same time we use a little bit of virtual progress bar so that speed up, so you actually don't need to wait for 5 minutes, maybe only wait much shorter time, but you get a sense that in the real task later that you do need to wait the right amount of time. So the exam mode is extremely important. Everyone probably agree that cryo-EM instruments really expensive. We really want to make sure we know how to do that exactly. We avoid mistakes, especially some really risky mistake that will cause damage to the equipment and the downtime of the equipment, right? So we implemented exam mode. We removed all this instruction text and audio and the video guidance, and we will check the user's actions in the VR and score against the SOPs that for this particular module, right? So then this SOPs we are co-developed by these cryo-EM centers through the merit badge working group. So and our target actually want to be 100%. All right, so we want to make sure everything is exactly right instead of the typical the class exams. You get 70 points degrees, right? Then you pass it. So so we want to be a little bit more stringent and high standard, 100% correct. So once the user finished this exam. Right, so the system, cryo-VR system, will score the operations against the SOP. So if we have not achieved 100% success, then you can get our error report and tell you what step you have made a mistake, and show you the list, so that next time you can pay attention to avoid those mistakes. To facilitate the review, so we also implement the playback function so that you can actually replay what you have done, right? So actually, we want to also enhance the replay with multiple view angles, either from your own personal view or maybe the over the shoulder view as well. But if indeed you have learned so well, you did this 100% correct, then you actually be able to get a certificate, show that that you have successfully completed this module. So on the left is just one example, right? So this is for the Witchboard SOP. So the certificate is actually we try to make it as a unique. Every certificate has a unique ID, with high level of security, so that indeed we can trust this certificate, and then it can which can be independently verified through our computer system. And then we also build in certain convenient features like the URL link or the QR code. Then you can use that to very easily check against our server. So to support this certificate and verification, we actually built this user management system so that you can log in with your ORC ID, keep track the progress of your learning, right, and your certificate, right? So, or if you just want a quicker test at the cryo-VR, you can just use it as a guest without logging. So, of course, then you want to be able to record your certificate, for example, right? So then, so far we just talk about the features that we need for the actual training, but sometimes we think a computer might be actually even do better than the real world. For example, in this category called hazard simulations, there. Right, so everyone knows that say the ethane gas is pretty risky. If you don't pay attention, you have too much leak, right? So it might cause a fire. In real world, we try the best not to get to there, but sometimes we might forget how serious this mistakes can be, right? In the computer system, in the VR, we do actually the extra luxury. We can actually simulate this fire hazard. And hopefully through this dramatic effect, VR effect, we actually help everyone to learn. We really need to pay attention to the safety procedures. So another aspect we have for implement is that VR is great. We fully believe the VR is very effective. But sometimes the VR, the requirement of a headset is a barrier for some of the users. So we also took the VR module, which share a lot of the code space and the models, so that we just strip away the requirement of a VR headset, turn the VR modules into a standard PC game, so that you're just using the keyboard and the mouse control, and then also be able to go through the procedures. Of course, a lot of this true interactive, nice features in the VR probably would be lost. But at least just give you a sense of the instrument and the overall operation protocols. The cryoVR is developed with close collaboration with many parties. So, right, for example, we collaborate with the NCCAT, where you are now, and we also collaborate with the other cryo centers like the SLAC Center and the Pacific Northwest Center, and also with the NCI's National Frederick National Laboratory for cryo. And we got the hope, especially to provide the pictures, operation videos of the certain equipment that we don't have in our Purdue cryo facility. We're grateful for this support. And also develop this standard operation protocols with the National Center, the Mary Batch working group. So far, we have implemented 2 SOPs that are generated by this working group, the Vichbar and autogrid clipping. So we'll continue to implement the other SOPs that will be finished in the future. So so now we'll just talk about what do you need in terms of hardware-wise to play cryoVR, right? So we started with this HTC Vive, which is kind of relatively high-end but the best quality, right? So we want to make sure the quality in VR indeed is good enough, right? So that it's can sufficiently emulate the real physical instrument and operations. So, but we do realize sometimes the cost might be indeed a barrier. So fortunately, the VR industry is progressing well, even with the current called Oculus Quest model, right? So only about $200, $300. This is already have enough performance to support the cryoVR level of this quality requirement. And right, the nice thing about the Oculus is that it's lighter and it's smaller and it's wireless. It's not attached to a PC, right? And it's also much more convenient to set up, and the working space is also very friendly. So in next few hours, you will have opportunity to try both the Oculus and the HTC Vive version of our cryoVR. Hopefully, you will get a test of that. So of course, our cryoVR projects are not done. We're still in the active funding phases. We'll continue to develop additional modules. Right now, we're developing the Leica GP2 plunge freezer. So with the focus on, for the next 2 years, focus on the tomography and field, so that we use GP2 plunge freezers to support, very often people use this to support this backside blotting of the cells grown on the grid. So we're also going to simulate the Oculus, the FIPSM instruments in the next year. So if you do have suggestions on what you would like to be simulated, please do not hesitate to let us know. And we try to disseminate our cryoVR as widely as possible. First, we have a website here, just purdue.edu and cryoVR, or you just Google cryoVR, you will find us. So all the cryoVR modules are freely available, and you can download for free from this website, right? And install and play. Then we also have a Twitter account to often tweet what are the new module we're working on, some working in progress, a snapshot, what do we have. And we also have created multiple shorter videos to introduce each of the modules, right? So so these videos are available on the YouTube. We have a cryoVR channel. We also open source our cryoVR code and the models, and on the GitHub, you are welcome to take a look if you are interested in helping us. Right, so you're welcome to contribute to this development as well. So just github.com cryoVR, and I think that's all we were going to cover in the presentation. So here we would like to thank our cryoVR team, Victor, myself, and Bill Wanderson, and Thomas Ross. And we have multiple students who are actively working on this. And we also have multiple team members in the past who contribute to this development. Last, I would like to thank the funding from NIH through this the transformative cryo-EM initiative that funded us to develop this. So I think that's all what we're going to say in the presentations. And of course, in next few hours, you will be able to first for the watch my students, Dao and Kadir, who is going to demonstrate this cryo-VR module to you, and then you can actually put the goggles yourself and try it out. But before we move on that, so Victor and I welcome questions, so we'll be happy to answer. Thank you.
They're clapping if you can't hear the sound pickup. So one question, since cryo-EM has been now used in a lot of applications, especially in the SARS-CoV-2 pandemic for structural studies, have you had a lot of good outreach and response from people interested in the cryo-EM workflow and say, well, I want to understand it more, and made use of the cryo-VR modules?
Yeah, so this indeed the COVID has caused some real limit us from actual physical interaction with the potential audience. So our feedback mostly through this virtual venues, right? The Twitter and YouTube channels. So indeed we when we tweeted out the new modules, right? And we actually received a lot of feedbacks from the Twitter followers, and most of them are really actually encouraging. I really like this, but some also, of course, have a pretty high standard. Really want us to make this simulation experience as close as possible, right? So we also tried our effort to write to directly to especially those kind of indie stage, right, minority serving institutes. So at least let them know that we have this kind of cryo-VR capability that allow them to virtually, experience some of the relevant equipment I mean, many of those institutes might not have even the screening facility there. They might not actually have the luxury to even just play and actually see those equipments. So, so indeed, we have got some positive feedback from those people here.
Along those lines, it might be pretty interesting because some places are interested in building out facilities. Since you've modeled out a facility, you might have now the ideal setup for someone to emulate.
Yes, yes. So this is something I do, Victor and I would do a real welcome actually from my, for example, your side, right? Yourself and your colleagues in your team, and also the audience. Tell us what would be the, say, equipment you really want us to simulate, right? So help us build a, kind of a priority list. So what would be the best, impact in the shortest and in the near future? Yeah.
I was just going to say, I think it would be really helpful to add a simulation of how to load grids into the instrument, because I know that equipment is very expensive, that if somebody does it incorrectly. If they could try it virtually before, that would be really interesting.
Yeah, so maybe I'll ask you specifically, we do have the auto grid clipping and the loading modules that you should have a chance to try out later today. Do you mean the side entry holder as well?
I think that, yes, the side entry is the one I'm familiar with. Which one do you have already?
We have the auto grid loading for the Titan Cryos, this really the modern new instruments. Yeah, we have been considering the side entry holder, but then we started look at it. A lot of new facilities now basically have this glaciers, right? So then basically side entry instrument become history quickly. So we're debating if we should do that or not.
We just use it to screen grids before we send it.
Yeah, definitely. We still have our own side entry holder instrument. We definitely feel that that is a real tricky one. We probably, if we get enough feedback requests, we probably will actually do it. Yeah.
For what I'm understanding, basically this one you require people have to very accurate hold them kind of vertical horizontally, right?
Yeah.
Without cleaving. So so that could be. Yeah, we did consider in the VR operations, although it's all virtual, right? We can reinforce those positions, those things, to make sure that you have.
Yeah, thank you for bringing that up. Yeah, that's definitely the type of feedback we want. It's help us to put the right a priority on the different things. Yeah.
Hi, thanks for the talk. I'm curious if you have any plans to model either a data collection or some sort of interface with serial EM, and then an idea that I just think would be cool would be to actually model the microscope optics, so you could go inside the microscope and see the different lenses at play and sort of see where you get the diffraction pattern versus where you get the reconstructed image.
Okay, that's a very good point. We have a sort of both. I would kind of divide what you mentioned into two major groups. The first group is the computer interface in data collection, right? So mouse click those. So those actually we consider probably not the best suited by the cryoVR, because cryoVR, the interface with all mouse click, the typing, the text, that are not the best. We sort of probably data is best served by other means for data collection. But for the optics, that indeed is something we think it might be actually really good for what we do. So so far we have not really done that, because when we do this, right, we have been debating, do we actually do just cartoon level, or do we do physically accurate level simulations? So Yeah, so ideally we probably should have a both, cartoon level, and if we zoom into detailed enough, will be physically accurate. So indeed, that is something we have been thinking, but it is currently it's beyond the scope that our funded scope. But definitely that would be something really useful for learning, especially for the small number of the users like you, right, who are truly interested in the optics. Yeah, that definitely would be wonderful. Yeah.